Well, I have an X-ray tube, I have a cathode, and I have an anode. I might have talked in the last video about the question I will give to Dr. Hani, which is the idea that I have something called filament current, something called filament voltage, something called tube current, and something called tube voltage. This means that the parameters on the machine itself are the milliampere second or the kilovolt, which is considered the tube current and the tube voltage. So what is the difference between tube current and tube voltage? And what is the difference between filament current and filament voltage? The whole idea is that I have a screen here. If it's clear and the sound is clear, I continue. I have here a filament, cathode, and anode. The filament itself runs on electric current and has a filament current that must be continuous, and it has a voltage difference. There must be a potential difference or kilovolt, so I need a voltage to move the electrons present in the filament wire to heat the filament. Therefore, I have a dedicated voltage for the filament and a dedicated current for the filament itself, which creates the filament current and filament voltage. What are their functions? The voltage present, which is averaged across the filament, is a very small voltage, not in kilovolts. We are talking about something in the range of 10 volts. The current flowing through the filament can reach a value of about 10 amperes. As I mentioned, I have electrons moving in the filament wire, and I want to provide them with energy, so I need to connect them to the filament voltage. What does the filament voltage do? It moves the electrons. If I increase the filament voltage, it provides more kinetic energy to the electrons moving through it. If I increase the current in the filament, it increases the number of electrons. If it provides significantly greater kinetic energy, it will increase the temperature of the filament more substantially. The increased heating of the filament will lead to thermionic emission, causing the liberation of electrons on the surface of my filament. Therefore, the number of electrons that will be produced is directly influenced by the filament voltage. The filament itself is running on the filament current, and the current flowing through the filament is important. Now, on the other side, we have my anode. For the electrons to move from the cathode to the anode, they need another voltage difference, or I have another kilovolt. This is the significant voltage difference that exists on the parameters I have in the machines, and this is what I work on. This provides the electrons to move from the cathode to the anode. I have the kilovolt, which is either 120, 80, 70, or any type of electronics that I use directly for the model I am working on. The increase in kilovolt value provides the kinetic energy of the electron, increases the maximum energy of the electron, and enhances the minimum energy of the electron that is produced from the anode. This raises the minimum energy present that will appear in the X-ray spectrum. The increase in voltage present in the filament itself will lead to an increase in quantity, so you might find some excuses telling you that this topic doesn't matter. Increasing the voltage in the setup, does it lead to an increase in quantity, quality, or just quality, or both? Logically, if I have 2 volts, does the voltage flow in the filament? Okay, filament voltage. If he came and asked you about the filament voltage, will increasing the filament voltage affect the number of X-ray photons? Of course, yes, it will affect the quantity, because an increase in filament voltage will lead to an increase in the number of electrons liberated from the filament, which in turn will increase the number of X-ray photons produced by the anode. However, there is no effect on the quantity of X-rays, but it does have an effect on the energy of the X-rays. Update on the assistance decision of the City Council. Thank you. In essence, you need to comprehend, fully and thoroughly understand what filament voltage does, what tube voltage does, and how filament current interacts with the permissive box. The filament current and the filament current flowing through it. An increase in the filament itself will result in an increase in the electrons that move from 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 the electrons. This statement indicates that when there is a substantial increase in the filament voltage, it will consequently result in a corresponding increase in the quantum level that is specifically related to X-ray production. This relationship highlights the direct impact of voltage changes on the quantum characteristics of X-rays, emphasizing the importance of precise voltage control in X-ray technology. Okay, what change occurs in spectrum A? When I talk about milliamps or the tube current or the filament current, any increase in tube current or filament current will lead to an increase in your quantum for the X-ray. There is no relationship with energy. An increase will lead to an increase in the quantity of X-ray, and it has no relation to energy. A decrease in voltage will lead to a decrease in the maximum current. Regarding the Kalman, what does it mean? If I am talking about it at this time for me, but if we focus on the discussion, it has no effect on it. Right, Dr. Hani? Can you hear me? Okay, Dr. Hani, did the burn reach you, or is there anything else? Can you hear me or not? Now you can hear me. Did you hear what I said, or not exactly the last 2 minutes? The last 2 minutes, okay? When I was talking about the effect of the 2 voltage, welcome to. All right. So to summarize what I just said, I mentioned that I have a filament and an anode, or the cathode and the anode. The filament carries a current, which I refer to as filament current. The voltage that drives the electrons within the filament itself is called filament voltage. When there is an increase in filament voltage, it will increase the number of electrons produced due to thermionic emission at the filament. Consequently, this will lead to an increase in the number of electrons prepared between the electrons and the atoms, resulting in an increase in the number of X-ray photons produced. The increase in the increase has led to an increase in the increase, right? And the film, you know, increasing the filament current will lead to an increase in the number of electrons obtained as a result of thermionic emission, because an increase in current generates higher heating, which facilitates thermionic emission and causes vibrations of the electrons on the surface. These electrons, which are formed at the bottom of the filament, want to move from the cathode to the anode. The number of electrons that move from the cathode to the anode is what I call the tube current. The increase in tube current is related to the increase in filament voltage and filament current. What is it about? It's about the film and about an increase in filament voltage and an increase in filament current will lead to an increase in the number of electrons. So, what is the increase in filament current? The increase in filament current is the voltage difference that drives the electrons from the cathode to the anode. The movement of electrons is related to the tube voltage present. For example, if the parameters are set to 80 kV, 25 kV, or any value. Close to the design I am working on, this drives the electrons. The more this increases, the more kinetic energy I provide to the electrons to move from the cathode to the anode. The more I increase the maximum energy of the X-ray photons, the more I increase the minimum energy of the X-ray photons. Right, Dr. Hani?
I have a question. Does increasing the tube voltage increase the energy of the X-ray photons and the number of X-ray photons because it increases the probability of interaction between the liberated electrons and the target? For example, if I only apply 70 kV, it produces a certain characteristic radiation. But if I increase it to 140 kV, instead of producing one characteristic radiation, it will produce two characteristic radiations. So, does it increase based on the lesser of the two? It will produce two. Does it increase based on either one of these?
I will tell her again. If I am talking about tube voltage or filament voltage, the question coming to you is whether it is filament voltage or tube voltage. All right. So, the tube voltage here is related to the energy of the spectrum. However, to reach that high kilovolt, you will need to increase it to reach that value. Consequently, you have increased two things. You have increased the quantity and you have increased the energy. Why? Because as you know, when you give more kinetic energy to the electrons to move from the cathode to the anode, you are introducing electrons with high energy. Now, the topic of characteristic radiation does not depend on kinetic energy or the legality of the electron. Characteristic radiation depends on the incident electron on the atoms present in the anode having energy equal to or close to the characteristic energy or the K energy of the electrons present in the atoms. Is that clear, Dr. Hani? But then I will take the larger part, which is the premise, as a result. Change always inherently occurs in the part that naturally depends on the interaction between the electron and the Coulomb field, naturally surrounding the nucleus. Now, since I inherently have greater energy, I will naturally be able to interact within the atoms or inherently interact with a large number of the X-ray photons. The interaction between the Coulomb force and the electron will occur in the nuclear field, and the energies will appear, as we mentioned, depending on how they interact with any zone around the nucleus. The closer you are to the nucleus, the more the characteristic radiation will appear, producing high energy X-ray photons. Now, this energy fundamentally depends on what? It depends on the energy of your electron that has undergone the incident, which is essentially driven by the kinetic energy you have, right? So, when we talk about quantity and energy, we are clear on that. The last time we were talking today, there are some questions and different things, such as the topic of the line focus principle and the anode angle and their relationship to tube rating. If you have many questions today, there are a lot of things that can be confusing, like the topic of the line focus principle and the anode angle and their relationship to tube rating and so on. Today we will talk about tube rating. Today we will talk about tube rating, specifically the line focus principle, calling chart, tube rating, and the anode heat effect. We will complete the section on X-ray and its components. To finish this part, we will discuss screen film radiography and digital radiography. Once we complete this section, we will move on to the next part. And hopefully, by tomorrow, we will be ready to discuss the next topic. So, have we finished this part? I want you to focus with me because the information today is not extensive, but it requires concentration to be understood correctly. If a question arises or if there are things in this section, it will be clear for you. I mentioned in the lecture, as I explained earlier, previously in our discussion, that I have the cathode and I have the anode in this context, and the electron moves from there. The cathode interacts with the anode to produce X-rays. The X-ray that is produced is supposed to appear in a specific direction or in all directions. The X-ray that is generated should appear in all directions, meaning it is circular in shape. I cannot control its direction, right? If this is indeed the anode, and this is the electron beam that is produced from the filament and incident on this part of the anode, This part that is produced from the anode, as we have previously discussed, 99% of the collisions that occur between the electrons and the anode result in heat. Only 1% of the collisions produce X-rays. This means that this area, which I call the actual focal spot, is the part of the anode where bombardment occurs between the electrons coming from the filament and the anode material. This black part is what is called the actual focal spot. This part is supposed to experience heating, meaning there should be a significant heating effect, or there may not be a heating effect. Of course, there is a natural process for the heating effect. So, that's why I told you, we will make my anode from a material that won't melt at high temperatures. However, this brings a problem because the anode will need to be cooled. For example, if I increase the currents from 30 milliamps to 100 milliamps, this means that the currents will increase. And if I have 100 milliamps, this means that the number of moving electrons will also increase. Consequently, the heat dissipation, or the heat from the collisions, or the heat produced in the area of the focal spot will also increase. This could lead to a problem where the anode itself might melt. So, what should we do to prevent this from happening? Well, they suggested that instead of doing this now, what's left? What is left? What is left? What is left? What? 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 So, it will create a better distribution of heat, which will allow the anode to withstand high currents and a high number of electrons. Does that make sense, or is there a problem? All right. So now we concluded that we will tilt the anode at a certain angle, which we will learn how to calculate, called the anode angle. Why? To increase this area, which in turn improves heat dissipation and allows the area exposed to the number of electrons to be larger, resulting in a better tube rating. What does this mean? It means that the heat capacity, or the anode's ability to withstand heat, is improved. So, has my actual focal spot increased or decreased? It has increased. Therefore, logically, the anode can withstand a higher temperature, which increases the heat of the head and the thermal capacity of the anode, allowing it to handle a higher current. Thus, in this case, I can provide a higher MA. Instead of giving 30, I can give 100. Therefore, this is the meaning of the term tube rating. The allowed MA that you can provide is large or high. You can give higher parameters. Why? Because you have enlarged your actual focal spot by increasing the anode angle. When we increase the anode angle through the tilt you made, you increase the area exposed in the beam of electrode. This is what the projection refers to. The radiation coming from the actual focal spot and hitting my receptor is incident on the receptor, which I refer to as the apparent focal spot or effective focal spot, right? Okay. Do you remember? When I increased my anode angle, what happened to the effective focal spot? when the anode angle was like that. If your effective focal spot was small, it would be small, right? Okay, now I have a problem. What is the problem? The actual focal spot is now like the X-ray source. I want you to imagine with me that I now have a point, and this is the X-ray source. I removed this X-ray source and gave it a certain dimension like this, and I have an object here that I am imaging. And the same object, I am imaging it here, and this is the image receptor, and I placed it here. Okay, in the first case, when my actual focal spot is small, this is in the initial situation with a small anode angle. All right, I haven't set my 3 yet, or the angulation is at a very small angle, so the anode angle is small. In this case, the tube loading is high, or the loading here has created a high heating effect on the anode, and your actual focal spot is small. However, when the beam is produced from this small point and falls on your image receptors, the image that will appear will be affected. Here, it will have a high level. In the case that your source has a certain dimension, or has a line, or has a specific location, or has an area, you may have a beam coming from this area, hitting this edge. It is very common for a beam to come from this edge and drop down here in this manner, creating an area called the penumbra. The penumbra area causes unsharpness or a blurring effect, making the edge of your object not clear, which increases the unsharpness or the blurring effect. Therefore, when I increased the focal spot, it created a problem. It addressed the heating effect or the tube rating, increasing the anode's ability to withstand the heat generated, but it also increased the unsharpness. To clarify this idea for you, I will show you right here. So don't disconnect with me now because this part is very important. Here I have the filament. This filament is inside the focusing cup. As we discussed earlier, we will go to the area that I mentioned a little, which contains the negative charge. Why? To focus the beam of electrons coming from the filament, the negative charge focuses the beam coming from the electrons. The electrons start to move and interact with the anode, and this way, the X-ray appears. This area is what I call the actual focal spot. This is the area that is exposed where the heat will be generated. 99% of the heat resulting from the collision will be produced here. Now, if I have, for example, 50 mA, meaning I have a current of 50 mA, it will create a heating effect of 3000 degrees C. If I increase the current, it will create a heating effect of 3000 degrees. If I now increase my current, what is expected if I increase from 50 to 100? What should happen is that the heating effect at this degree will be 3000 or higher. That's why I want to enlarge the focal spot area, or the actual focal spot area that I mentioned, so it can withstand the temperature. If I increase it, the amount of increase in temperature will actually be less because you have distributed your heat better over a larger area. So, by enlarging the actual focal spot, what I am doing with the modulation is giving the anode an angle, so it can withstand a higher current. The current here reached 90 milliampere and gave me the same temperature that was present. Therefore, the larger the actual focal spot, the better. I want this concept to be in your mind. If the focal spot or the actual focal spot is larger, then I can increase my tube rating or increase my heat capacity. Thus, my anode can withstand high temperature or high milliampere parameters, right, doctors? But the problem is that the increase in the focal spot size, well, there is something called motion, slightly sharpness or motion. Now, if you come to perform a scan for the patient, this scan takes a very short time. For example, someone might tell you that there is a relationship between increasing the milliampere or increasing the current. You can reduce the scan time. Why? Because you are providing a large quantity of X-ray in a short time, just like when you give a low milliampere over a long time.